Hello everyone, my name is Komal Jangid, and in this presentation we are going to talk about NoSQL database. So first of all, we'll see what is NoSQL database, then we'll discuss its type and some of its advantages. Then we are going to see some real world use cases of it, and then we are going to address some of its misconceptions. So NoSQL database is an effectively managed unstructured data enhancing data handling capabilities. These databases provide flexibility in data models and can scale easily to meet increasing demands. It has variety of data types. It can handle various data types and structures unlike traditional databases which are often rigid. Then it has high performance. It is optimized for high performance, facilitating quick data retrieval, and they are particularly suitable for applications that demand fast access to large volumes of data. So now we'll see the types of NoSQL database. First is key value stores. It utilizes simple key value pairs to manage data. Redis and DynamoDB are prominent examples of this. Then we have document stores. It stores data in document format. Which enables nested structures. Its examples are MongoDB and CouchDB. Then we have column family stores. It includes Cassandra and HBase, which organize data in columns for efficient storage and retrieval. Then we have graph database, and some example of graph database is Neo4j and ArangoDB. It exemplify graph databases which emphasize relationships, making them suitable for social networks and recommendation systems. Then we will see a little history of NoSQL database from 2000s to the present time. NoSQL database was introduced to overcome the limitations of relational database in handling unstructured data by and it made a pivotal shift in data management. Then Amazon Dynamo was one of the first NoSQL system designed for high availability and scalability, influencing later NoSQL technologies. Then Google Bigtable emerged as another foundational NoSQL database, providing a scalable architecture for handling large datasets across distributed systems. Then, the NoSQL landscape expanded rapidly with advancements in big data technologies and cloud computing, leading to various NoSQL databases catering to diverse needs. So, some of the key features of NoSQL database are scalability. We can horizontally scale our NoSQL database, which enables organizations to add more servers easily as demand grows. It provides us with flexibility like schema-less designs, which allows NoSQL database to handle various data formats without rigid structures. Then we have availability. It is designed for distributed architectures to maintain uptime and reliability across systems. And it provides us with high performance, which is like it provides us with optimized quick read and write operations, which ensures low latency for high demand applications. Then we have relational database versus NoSQL database. Now we are going to see some of the key differences and use cases in data management. Uh, so first we have relational database. It utilizes structured query language for data manipulation, whereas NoSQL supports dynamic schemas for flexible data models. Then, relational database employ predefined schemas for data organization, and NoSQL database is designed to handle unstructured and semi-structured data. RDBMS is best suited for structured data with defined relationships, whereas NoSQL is ideal for applications requiring high scalability and agility. Then, transactions in RDBMS are ACID compliant, ensuring reliability, whereas transactions in NoSQL may not be ACID compliant, focusing on availability. RDBMS is ideal for applications requiring complex queries, and data integrity is prioritized with normalizations. Whereas NoSQL can offers various data models, document, key value, column family, graph. RDBMS is commonly used in financial systems and enterprise applications, whereas NoSQL is best for real-time applications and big data analytics. Then data is stored in tables with fixed rows and columns in RDBMS, whereas in NoSQL data can be distributed across multiple servers easily. And in RDBMS, scalability often requires vertical scaling, but in NoSQL database, we can scale our system horizontally. Then NoSQL is commonly used in social networks and content management systems. Now we are going to see the difference between the data models and transactions of RDBMS and NoSQL database. So in data model, RDBMS uses a structured data model based on tables and relationships, whereas NoSQL employs an unstructured or semi-structured data model, allowing for flexibility. Then in RDBMS, it is ideal for complex queries and transactions, and NoSQL can handle various data types like document, graph, and key value pairs. Then RDBMS enforces schema ensuring data integrity, and NoSQL allows for dynamic schema evaluation. RDBMS is less suited for hierarchical data, whereas NoSQL excels in managing large volumes of varied data. Then, looking at transactions in RDBMS and NoSQL, transactions in RDBMS is ACID compliant, ensuring reliable transactions, whereas NoSQL follows base principles, focusing on availability and partition tolerance. The ACID guarantees consistency and isolation of transactions, and base allows for eventual consistency suitable for distributed systems. RDBMS transactions can handle complex operations safely, whereas NoSQL transactions are more flexible but less strict. ACID compliance can lead to performance overhead, and base compliance supports scalability across distributed networks. Now here we are going to look at some of the NoSQL use cases. So first use case is social networks. NoSQL databases are adept at managing complex relationships and interactions among users in social platforms. Now, NoSQL is also used in real-time analytics. NoSQL databases excel in applications requiring immediate data insights, enabling timely decision making. Then we have IoT applications. NoSQL is also used in IoT applications because it is ideal for processing vast amounts of data generated by connected devices, ensuring efficient data handling. Then we have content management. Content management also uses NoSQL database as it offers flexible storage solution for diverse formats and media, supporting easy retrieval and management. Now we are going to see when should NoSQL be used. When we are using distributed systems, NoSQL should be used as it supports applications that operate across multiple geographic locations. Then when we are dealing with high volume data, because it is ideal for handling large data sets where performance is critical. And when we want to use flexible schema, then also we can use NoSQL database as it accommodates changing data structures without rigid schemas. And if we want rapid development, then also we can use NoSQL as it facilitates quick iterations and deployment, reducing time to market. Then here we are going to talk about some of the NoSQL data misconceptions. The first misconception is NoSQL means no NoSQL. This is a misconception because many NoSQL systems supports SQL-like queries, enhancing its usability. Then the next misconception is NoSQL is only for big data. While this is not true, NoSQL is popular for big data, but NoSQL databases are also effective for smaller applications. And the next is NoSQL lacks consistency. Modern NoSQL database use various strategies to ensure consistency, addressing this concern. So now we are at the conclusion. The conclusion is NoSQL database provides a variety of benefits, including flexible data models, horizontal scaling, lightning fast queries, and ease of use for developers. NoSQL database come in a variety of types, including document stores, key value databases, wide column stores, graph databases, and multi-model databases. So this is the end of the presentation. Thank you for listening.